Hello, I'm going to talk about the experiment performed in HPTLC. Our aim of the experiment is to determine unknown concentrations of benzophenone and benzhydrol in a mixture using HPTLC. So here is the outline of my talk. First, I will give an introduction on HPTLC. Then I will talk about various advantages of HPTLC over TLC and HPLC. Then I will talk about the working principle of HPTLC, then experimental apparatus and reagent chemicals used in HPTLC, and finally I will discuss the experimental procedure. Now first, what is HPTLC? So HPTLC is the high performance thin layer liquid chromatography. So before that we should know what is chromatography. So chromatography technique is used to separate various components present in a mixture due to their respective affinity between a mobile phase and a stationary phase. So various types of chromatography techniques are used. They are paper chromatography, liquid chromatography, gas chromatography, ion exchange chromatography, gel permeation chromatography, and thin layer chromatography. So the thin layer chromatography is mainly used to separate non-volatile components from a volatile one. So TLC, it is an important technique for monitoring reactions, identifying various components present in the reaction, and for determining the purity of product. So high performance TLC, which is also called HPTLC, is an advanced or enhanced version of TLC which includes more automation and allows higher resolution for the analysis. So here we will talk about various advantages of HPTLC over TLC. So auto samples of HPTLC makes better than TLC since it overcomes the manual error and it provides high resolving power, reduces solvent consumption, utilizes advanced UV visible and fluorescence detectors, and it enables simultaneous analysis of multiple compounds, and it is highly precise than TLC. So here I will talk about various advantages of HPTLC over HPLC. So here right side there is an image of HPLC experimental setup. So here in HPTLC the preparation of sample is very easy and the consumption of solvent is very less compared to HPLC. In HPTLC the maintenance costs are very low and here no effect of turbidity of sample on analysis, and here whole spectrum can be seen, and it is highly flexible in selection of mobile and stationary phases. In HPTLC the per coated TLC plates are available in low cost, and in HPTLC it provides better analytical accuracy and precision since sampling and standard can be processed simultaneously. Now here I will talk about the working principle of HPTLC. So the chromatography, it mainly uses a mobile phase and a stationary phases. So in the figure there is a stationary phase, the TLC plate, and a mobile phase with the solvents. Here the mobile phase that rises off on a stationary phase due to the capillary action. The stationary phase used in the TLC plate is a silica coated on aluminum sheet, while the mobile phase is a solvent which can vary according to the separation requirements. Since the components of mixture has different affinities towards the mobile and stationary phases, so they will travel different distances over a plate. So for example, a non-polar organic compound will have more affinity towards acetone than silica. So when a mixture is brought in contact with silica and acetone, the distance traveled by the non-polar organic component will be more due to greater affinity towards acetone. So in contrast, the polar component having relatively greater affinity towards silica will get absorbed on the silica plate and remains almost stationary. So there are two different terms which we should know while operating HPTLC. So they are the partition coefficient and the retention factor. So partition coefficient is defined as the ratio of equilibrium concentration of an analyte in the stationary phase to that on the mobile phase, while a retention factor is defined as the ratio of the distance travelled by the solute to that travelled by the solvent front. So a higher partition coefficient indicate that the mixture has more affinity towards stationary phase and it will migrate relatively slowly. So in the experiment, the solvent to be used is mainly governed by the retention factor of the solvent for a particular solute. Why is it so? Because if you will choose a better retention factor of a solvent and solute combination, then we can achieve a wide difference of retention factor values for different solutes, and it will help for better separation of components present in a mixture. So here are the experimental apparatus used for the HPTLC. The first one is the TLC plate, which is the silica coated over a aluminum sheet, and the second one is the applicator, which is allows to apply sample over the TLC plate, and the third one is the glass developing chamber, where the mobile phase is used to travel over a silica plate, and the last one is the TLC UV scanner, which is used to scan the various bands formed in the TLC plates. So here are the reagents and chemical used in this experiment. So we'll use two standard solution, benzophenone in methanol and benzhydrol in methanol, and also we'll use developing solvents in a ratio 3:1. So the developing solvents are N-hexane and toluene. So then I will talk about the experimental procedure for this HPTLC. I am going to show the experimental apparatus and the chemicals and reagent used for this HPTLC experiment. So first we have to prepare these two standard solution of benzophenone and benzhydrol. Then we will prepare a mixture of unknown concentration from this benzophenone and benzhydrol. Then we will prepare various bands in this TLC silica plate. Suppose we will use by using this applicator, we will prepare the band. Let's say we have 15 bands. So first 6 are from this benzophenone, second 6 are from the benzhydrol, and the last 3 will prepare sample of unknown concentration. So after once bands are formed on this plate using this applicator, then we will prepare a developing solvents from this N-hexane and toluene in the ratio 3:10 inside the glass developing chamber. So once the solution is ready, we will dip this plate inside this glass developing chamber, and we will keep for some time so that the mobile phase, which are N-hexane and toluene, will travel to this distance. So once it reached till this point, we will dry using this dryer, this solvent. After drying, we will see the bands inside this UV chamber. So we will see at 366 nanometer wavelength. So you can see the bands are formed. So you can see the first 6 are from benzophenone, next 6 are from benzhydrol, and last 3 are from the samples. Then once scanning, we'll see the bands formed. Then we will scan these bands using this CAMAG TLC scanner 3. So, and we will use this Vision CAT software for this. So So this scanner, it will scan the various bands, and it will give the absorption peaks. From the absorption peak versus various concentration of the standard solution, we will prepare a calibration line, and from this calibration curve we will get the concentration of unknown sample. So thank you.